Hello students, it's Professor Rowley again. Hopefully my videos get better. You'll have to bear with me. I've never done this before. We're getting ready to look at section 5.2, systems of linear inequalities in two variables. Systems, the word is systems, and remember systems consists of more than one, in this case, linear inequalities. So if I look down here at number 1, we're going to be graphing two linear inequalities on the same xy coordinate system. So here's the example. It says, graph the solution to the system of inequalities. This shaded region is called the solution, or the feasible region. Find the corner points of the feasible region, and C is the feasible region bounded or unbounded. So we got a lot of work to do there. I'm assuming that you have this sheet printed or available to you. It is on Blackboard, so you can just go in there and download it and print it, or at least have it available. Here we go. Number 1. X minus 2y is greater than or equal to 2. So we're going to graph that one first, and then we'll graph this one on top of it, and then we'll discuss what the meaning is. So I'm looking over here on paper, and I recommend two different color pens. So I have a purple and a red. So my purple inequality, I'll graph the first one. So this is number 1, x minus 2y is greater than or equal to 2. So remember that with this, it's going to be solid, the line, not dotted. And everything pretty much from now on, we're going to be working with solid lines. So don't worry about those dotted lines anymore. Just a heads up on that one. To graph this, we look at the equality and graph the intercepts. And you'll get much better at these intercepts. So when x is 0, I'm going to put 0 in here for x. Right, that gets wiped out. Divide both sides by -2. And you get y is equal to -1. So there's your y-intercept. And now I'm going to start over with my x minus 2y equal to. I'm going to substitute 0 in for y, and I get x is equal to 2. There we go. Those are my two intercepts. So now I'm going to come over here to my sheet and plot those two. 0, -1 is right here. And what's the other one? 2, 0. And I'm going to take my straight edge, and I'm telling you guys, I'm having a hard time holding a camera and using a straight edge, so I'm going to free hand this one. And that is the purple line, which represents this first one, this purple. And now I have to decide, do I shade on the left side or on the right side, or above or below? So I'm going to take my test point 0, 0, and I'm going to put that in here. So I'm going to test. Excuse me. Into the inequality. So x minus 2y, you go back to the greater than or equal to 2. Substitute in 0. And that's all 0. Is that greater than or equal to 2? Nope, that is false. So we shade on the other side. Shade on opposite side of 0, 0. All right, now what does that mean? Now this gets confusing at some point. Some of you are going to catch on really quickly. Some of you are going to say, what? You'll figure it out eventually. We're going to have enough practice. So 0, 0, that remembers right here. So the side of 0, 0 is this side. So we need to shade on the opposite side, because if 0, 0 is false in the inequality, every point over here is false in the inequality. Now we don't want to test them all. That would take the rest of our lives. So we are going to shade on this side. You just only need one test point. There we go. There's our first inequality right there, graphed here. Now I'm going to graph this one. Now some things I probably should write on here, and I just dropped my pen, so I'll use it, that this is a 2 and this is a -1. That might be important later, so I don't want it to get forgotten. Now let's look at the second one. The second one is x plus y less than or equal to 5. And it's a system, so they're going to be plotted on the same xy coordinate system. And it's solid. Then I'm going to look at x plus y equals 5. Put my intercepts in there. So can you tell me when I put x equals 0, what I get for y here? A 5. If I put y equals 0 in there, what do I get for x? A 5. So 0, 5, 5, 0. I'm going to come over here. 0, 1, 2, 3, 4, 5 is here. And 5, 0 is 2, 3, 4, 5, 0 is right here. Okay. Now I should have made a better worksheet, but that's okay. I'm going to connect these and go a little bit beyond. I don't have the greatest looking XY coordinate system. That's okay. And which side do I graph on? Now before I do that, I need to make my purple inequality a little bit better. And so what I want to do is extend this. If you don't mind extending this, I didn't see this coming. I could have made a better worksheet, but that's all right. Here we go. So I just wanted to make sure you know that this goes on forever, this inequality. It's called a shaded half plane, so half of the piece of paper is being shaded. And I just wanted to make sure we saw this corner over here, where these are coming together. Now, my red, I need to know which side to shade on, the red line. So I'm going to go back to my 0, 0. So we're going to test 0, 0 in the inequality. And that is false. Excuse me, I just put it in the same one. Let's go back. I need to be putting it into x plus y. I don't have you all here to help me out. Sorry about that. I was testing it in the wrong one. Excuse me. We'll just get rid of that. Forget that happened. Let's come over here, because we just did that up here. Okay. I was putting it in the wrong one. So let's put 0, 0 in here. Is 0 less than or equal to 5? That is true. So you shade on same side of 0, 0. So over here, here's 0, 0, and here's the red line. Now you're going to have to ignore all purple, pretend like it's not even there. And we are going to shade on this side. So what you do, I recommend going up to the line, touching it, and pulling back like this. I know it sounds crazy, but sometimes it's important to know how far to the line the shading is. I'm going to pull my purple lines a little bit further. Okay. So this is what a system looks like. Now, one thing you need to notice is that you have your two lines, And notice here there's no shading. So there are no solutions here that fit this system. Now remember, there's just a bunch of ordered pairs in here. How many ordered pairs are there? There's this ordered pair, this ordered pair. There are many ordered pairs, infinitely many ordered pairs here, but none of those XY pairs will satisfy that system. Now, there are infinitely many ordered pairs here in this region. These are called regions. This is like region 1, a region 2, region 3, region 4. These are 4 different regions. Now, look over here. Only red is shaded, so the points, the infinitely many points here will satisfy the red inequality, but not the purple. Now, if I come over here, there are infinitely many, but they only satisfy the purple inequality and not the red. Now, here, all of these ordered pairs will satisfy both of them. So our solution, so it says right here, graph the solution to the system of inequalities. Okay, and that's going to be called, we'll call it the feasible region or the solution region. So right in here, what normally gets done is that this kind of gets shaded a little darker, like that, to emphasize that this is the solution to the system of inequalities. So to show every single one of these points with this boundary here and this boundary here will solve everything in these 2 inequalities. Now, this is called the feasible region. Okay, the feasible region. Got it? Now, one more thing. It says find the corner points. And then we're supposed to state whether or not this feasible region is bounded or unbounded. All right, so corner points. Corner points are kind of interesting. You got to think about a room and the corners of a room. This region has only one corner. This is considered a corner. Okay. Because in here, it just keeps going. There are no more corners in this room. It's just like an infinite room here that goes on and on forever. And you have only one corner. And a corner is a place where 2 lines come together, or 2 walls if you're looking at a room. And that corner point is special. So let's come over here and look at the corner point. We only have one corner point. Sometimes we have more than one corner point. In this case, we're looking at a simple example, our first example. And that corner point, remember, is the intersection of the 2 lines. What, the red and the purple line. Okay. Let me back up. All right, so corner point is the intersection of the red and the purple lines. Now, the red line is, so I'm looking at the red line. Is the line x minus 2y equals 2, and the purple line is the line x plus y equals 5, right? Because we graph those 2 lines using intercepts above. So those were the equalities. Now the equalities are the actual lines, the inequalities are the shadings. So to find an intersection of these 2, we've done before, okay? We have done this before. So what we're going to do is find the intersection of the 2 lines by using a matrix. So 1, negative, 2, 2, 1, 1, 5. Go put that in your calculator in the matrix. We're going to do RREF. And I've done this ahead of time. and I got 4, 1. 4, 1. I think that's correct. Looks about right. You can always check and see if 4, 1 works in here. The thing is, I haven't done it in my calculator. I did not plan ahead. Let me see. 4 minus 2. Yep. 4 plus 1. Yep. Okay. So we're going to pretend like I just put that in my calculator. Let me plan ahead next time. Do our area, and you should get this as your solution. Remember that this means x is 4 and y is 1. So the corner point, back to that, is 4, 1. So we are answering part B of the worksheet, which is like find all corner points. And we did that by using a matrix. Now you look at Math Excel, they're not going to use a matrix. They're going to do everything by hand, but we like that shortcut, so we are definitely going to use it. Now the final thing on this worksheet, at least the first problem, and then we'll take a break, is the feasible region bounded or unbounded? So bounded means bounded on all sides. Unbounded means it is not bounded on all sides. So if you look at this region, it's only bounded by this line, and then this goes on and on forever. So we consider this region unbounded. All right, that's enough for now. I'll come back and give you a video on number 2. Have a good day.